In lesson 12.4 here, we're going to look at finding probabilities of multiple events, independent and also dependent. Multiple events meaning you're doing more than one event. And basically the rule says you multiply the two probabilities together. Okay? Independent, again, is a sequence of events where one event does not affect the other. They're really independent of each other. The outcome of the first has no effect on the outcome of the second. So if we look here, Gerardo has 9 dimes, 7 pennies. He randomly selects one coin. He looks at it and he replaces it. And these are key words you got to look for if there is replacement or if there's not. He then's going to select another coin. So if you put it back in, you have the same number to select from as you did for the first draw. That's what makes this independent. So what is the probability that both the coins he selects are dimes? So what we want to do is we want to look at what's the probability of getting a dime and a dime. So I'm going to do probability of a dime on the first draw, and then I'm going to multiply it times the probability of a dime on the second draw. If you notice, 9 plus 7 is he's got 16 coins in his pocket. So the probability of a dime, how many dimes there are? 9 out of how many total? 16. Okay, he put it back in, so we still have 16 coins in the pocket on the second draw, and he still has 9 dimes, so it would be times 9 over 16, and if I multiply that, that would be 81 over 256. 16 squared is 256, and I would suggest dividing these. That's going to be about 0.316 or about 31.6% probability. So you multiply the two probabilities together. 3 independent events. When 3 dice are rolled, what's the probability that 2 dice show a 5 and a third dice shows an even number? So let's just clear this out of here. So we've got 3 events. Now I'm going to multiply all 3 probabilities together. So probability of getting 5, 5, and even. I'm going to multiply all 3. I'm calling the first event A, B, and C. So the probability of a 5 times the probability of a 5 times the probability of an even. And you're thinking about a standard die here. So that would be, there's one 5 out of 6. There's 1 5 out of 6. And then an even is 3 out of 6. If you want to reduce that to a half right away, you could. If I multiply those 3 together, I'd have 1 times 1 times 1, which is 1 on top, 6 times 6 times 2, which is 72. So it's 1 out of 72, and if I divide that, you could do that on the calculator to check it, it's about 0.014, or about 1.4% probability. So the probability of getting a 5, and an even is about a 1.4% chance. Now this last part of this lesson, we're going to change gears and go over to dependent. That is when the outcome of the first event affects the second one. And a lot of times that comes from no replacement. What makes it dependent is after the first draw or whatever we're talking about, there is no replacement. That means there's less to choose from on the second. You're still going to multiply the 2 probabilities together. So if we look at this, it says the host of a game show is drawing chips from a bag to determine the prizes for which contestants will play. Of the 20 chips in the bag, 11 say computer. So we got 20 chips. 11 say computer. 8 say you win a trip. 1 says a truck. If the host draws the chips at random, does not replace them, find each probability. So I want to do probability of a computer, and then I want to multiply it times the probability of a truck. It's just this is dependent because once the chip's drawn out, we're not replacing it. So on the first one, the computer, there is 11 out of 20. Now, I drew out a computer chip. First event happened. This is what makes it dependent now. On the second one, probability of a truck, well, there's still one that says a truck, but now there's only 19 left. If I multiply, that's 11 over 380. If you actually divide, 11 divided by 380, it's about 0.03. This one I went to the nearest hundredth, or about 3%. If you want to go to the nearest tenth of a percent, you could have went to one more decimal place there. Okay, what's the probability of getting 2 trips? So probability of a trip on the first draw, and then a trip on the second draw. And when we look at the second one, the first one's already going to be drawn out, or a trip is drawn out on the first one. So probability of a trip would be 8 out of 20. Now on the second draw, I've already taken a trip out, so now there's only 7 that say trip left out of 19. This is what makes it dependent now, because you've already drawn a trip out on the first one. We can do a little reducing here. 8 reduces, that's going to reduce to 2 out of 5. 4 goes in there twice and in there 5. So now I have 2 times 7 on top, which is 14. 5 times 19 on the bottom, which is 95. And now this one I actually went to the nearest thousandth. And if you go to the nearest percentage too, that's fine. So if you said about 15% here and went to 0.15, that would be okay. So dependent events, outcome of the second is affected by the first. We got one more example with dependent that we're going to look at here in this lesson. 3 dependent events. You're going to multiply all 3 of them together. Probability of a heart times the probability of a heart times the probability of a spade. And key word here again are words without replacement. So you draw one out, you keep it out. So probability of a heart. Now, remember there's 52 cards, 13 of each suit. Things you have to know about card decks. So probability of a heart, there would be 13 hearts out of 52, but I drew out a heart. Now it's only going to be 12 hearts left out of 51. And then how many spades? Now we're switching to a different suit, so there's still 13 spades left, but I've already taken 2 cards out, so now there's only 50 left. So if you go through and multiply here, and you could do some reducing or multiply. You should get, and if you could do the calculations, do 13 times 12 times 13 equals that, whatever, and then 52 times 51 times 50, and then divide them. You should get about 0.015 or about 1.5%. Okay? If you want to reduce first, I mean, you could have reduced the 13 over 52 to 1 over 4 and done some other reducing and canceling. Either way you do it, whether you just divide at the end or reduce first, you should get about a 1.5% chance.